Now RT, which is the radiographic testings. Okay, I mean, so far, whatever the technique that we have discussed, they all are under the category of the NDT. Okay, so testing is a non-destructive NTD. NDT NDT method that uses X-ray. Here, what it is going using X-ray or gamma rays. We have the pattern, like, I mean, we have the electromagnetic waves, here X-ray, UV rays, visible light, ultraviolet, and these all light, right? In which we have the gamma. If we talk about the gamma rays and X-rays, they are having the high frequencies. Okay, it means they are having the low wavelength. If we talk about as compared to the wavelength, visible light, they are having in mediate wavelength, and mediate uh, we can say mm, medium. You're right, medium. It's a very medium wavelength and medium frequency. Suppose here is a visible light, this one. So if we go with the left side, there frequency will increase and wavelength will decrease, and we go right hand side. Okay, then whatever the light categories that we are having here, they all are would be having a high wavelength and low frequency. So for the right side, less frequency, high wavelength. For left side, we are having high frequency and less wavelength. Or you can say the short wavelength. Okay. So here we use X-rays or gamma rays to inspect the internal surface structure of the material and detect the defects such as the cracks, voids, inclusions, and porosity. Sorry. Okay. So what are the key features of the RT? Detect the internal and surface defects, can be used on metal, composite, ceramics, and polymers. Provides the permanent radiographic images for documentation and review. What are the principle? What is the working criteria? Okay, the RT works by passing X-rays or gamma rays through a material. The rays are absorbed differently by different densities within the material. Okay, so the absorption power of any rays of material is different at a different densities. Okay, so denser areas, we can say the solid material absorb the more radiations and appears the lighter on the radiograph. Okay, defective areas like the crack, voids, porosities, they are basically having the less denser. They absorb the less radiation and appears the darker on the film. So what is the working condition? I mean, when we pass the X-ray or gamma rays through the material will absorb the more radiation if they are having the high density. Okay, and if there are no any defect, it means they can be categorized as a higher or having the high density, right? And if they are having the high density, it means it will be absorbed the more radiations. And if they have absorbed the more radiation, it will appear lighter on a radiographic film. Okay, but if they are having any defect, cracks, they are, and obviously they are having the defect on that, it means they are having less material, and due to that you can say are basically lighter, or you can say the denser, less denser. Okay, if they are less denser, then it means it will be absorbed less radiation, and if less radiation has been absorbed by the material, then it will be appearing the darker on the film, and then we can easily detect the problem or defect. Okay, with the help of the darker or the lighter. Okay,